Lesson 2.4, reflections of function. So you learned how to move things left and right and up and down. Those are just translations, which is a type of transformation. We're hitting a second type of transformation, which is called reflections. What is a reflection? What is a reflection? A reflection. Reflection. It is a transformation. Transformation. In which a figure, that could be a shape or a curve or a line or a funny looking graph, whatever it is, in which a figure is reflected. Oh, get that. Reflected. Over a what? Over a reflection line. Oh, man.
This is difficult.
So if you pick a line and you reflect something over it, you'll get a reflection over that line. Now, typically, you will reflect things over either, don't have to draw this, but the x-axis, in which case, that would be reflected. Yes, see that?
See.
Or you might do it over the y-axis, in which case, this would be reflected. Something like that. This is a reflection in the x-axis. This is a reflection in the y-axis. You could also reflect things over the line y equals x. That actually happens a lot. It's harder to do, but basically let's not waste our time, but if we had something like that, it would look like that. Yeah? Okay, carry on. Except it was reflected, yes. Other than being reflected, it's the exact same. Really good analysis there, my friend. Okay. Paying attention. We said we could graph, those are the three different ones, and we're actually going to pay attention because we're going to do all of those three things today. So let's take function notation, g of x.
Is this an example?
This is, nope, this is still in your notes. G of x is equal to f of negative x. Now, what does this mean? This means anywhere I see an x, I'm going to put in negative x instead. So any x coordinate of a point is going to become the opposite. Instead of positive, it's going to be negative. Instead of negative, it's going to be positive.
What happens if it's already negative?
So think about it. Think about it. If I take all of my x coordinates, my x values, and I make them negative x values, which line am I reflecting over? The y-axis, okay? So this right here is a reflection,
Do you know why?
of
Dude,
f
before
of
you
x
speak, reflect on your past
in
choices.
the y-axis. What does that mean? If you looked at the y-axis like it was a mirror, you'd see the same shape on this side as that side. Okay?
X.
I should say x, f of x. Right. Okay. Let's do another one. Let's consider h of x. Let's say we take h of x and we take f of x and we make all of the values that have come out of the function, we change the sign. If they were positive, we're now going to make them negative. If they were negative, we're now going to make them positive. All of the values that come out of the function. So if something came out here, we're going to actually make it negative. If something came out here, we're going to make it negative. If something came out here, we're going to make it negative. Does that make sense? If something comes out here, we're going to make it negative. Negative and negative is a positive. Which line have I reflected over? The
Can you
x-axis.
explain one more time what f is? I always forget.
It's just a function. Okay, so if I take all of the output values of my function and I change the sign, I'm going to cause a reflection of f of x in the x-axis. There is a third thing that we can do. Q of x. And watch, we're going to take f of x. We're going to negate, we're going to opposite all of the outputs and all of the inputs. See that?
Yeah.
Every time we see an x, we're going to replace it with negative x. And whatever comes out, we're going to flip the sign of that too. This is going to cause a reflection. Watch this. It's going to cause a reflection. Let's say you had a point here. It would get reflected over the x-axis
And then across.
and over the y-axis.
Ooh.
See that?
Yeah.
Okay. And you can do that with points. You can do it with curves. You can do it with shapes, whatever it is. This is a reflection of f of x in the y-axis and x-axis. So again, it does not change the shape, it does not change the size, it just reflects it, it flips it, or yeah, perfect. Example 1, graphing reflection. So we're given a function, f of x equals the square root of x plus 2. So it's a transformation of the base root function. We're going to write an equation to represent each of the following and then sketch them on the graphs provided there. So the first thing that we're going to do, and I'm going to just write down f of x equals radical x plus 2. So first of all, quick review. What's happening to the function square root of x?
I don't know.
Getting square rooted.
Okay, so this is the function. Done. Thanks very much. What transformation has been applied?
Oh, it's going up 2.
A vertical translation up 2 units. Good.
Good.
So on your graph, basically what A says we're going to do, h of x is going to be a reflection in the y-axis. We'll take a look at your notes above. What do we need to do to f of x in order to create a reflection in the y-axis?
F of negative x.
We're going to do f of negative x. Okay, so now look, what happens to this function everywhere we see an x in f of x, we're going to sub it out for a negative x, because that is the defining characteristic of the function h of x, which is a new function we've created based on this criteria. It's going to be a reflection in the y-axis. So what we're going to do is we're going to take our graph, which you have. It looks like, and the first thing that we're going to do is draw f of x. Okay, f of x is a square root function, which would look like this. Don't draw that. I'm going to erase it because we are having a vertical translation up 2. So I'm going to go 1, 2, and then I'm going to draw it.
Should we draw now?
So go ahead and draw that, but make sure that you're going through 0, 2, 0, 2. You're going to go through 1, 3. You're going to go through 2, 6. That's wrong.
I was going to say 2, 6.
That's wrong. I'm doing it
Maybe you should have
backwards.
quickly said it.
Okay,
No.
this one is correct. 1, 3 is correct. But then it would go through 4, 2, so it's going to go through 4, 4. It's over here. And it would go through 9, 3, so it's going to go through 9, 5.
Too far.
Okay, if you don't have room for that, that's fine. Okay, that is our function f of x that we're given. And basically we have all the key points that we know from the base function.
Upper up 2.
And no, we already did that. All we need to do now is what? We need to give the opposite of the x coordinate from each pair. So where we had 0, 2, it's still going to go through 0, 2.
Oh, it's only the x.
But now instead of 1, 3, it's going to go through negative 1, 3.
The y stays the same.
The y will stay the same, only the x will change. Instead of 4, 4, it's going to go through negative 4, 4. Instead of 9, 5, it's going to go through negative 9, 5. And you can draw your curve. And again, mine won't be as perfect as yours because you have a nice graph for yourself.
Flip.
So the image points have the same y coordinate as the original points, but they have the opposite x coordinate. The sign of the x coordinate is opposite. Okay, let's talk about domain and range. We're going to do it for both of them. So we're going to do for f of x, the domain, that's our original graph here. What values of x are included in this function? Should be experts at this by now.
Can you say that one more time?
What values of x
Oh.
are included in the black dotted line?
0, 9.
1, 4.
0 all the way up. All of them, not just 0, 1, 4, and 9, not just those. Every single point in between, every single real number, all the way from 0 to infinity. Okay? X greater than or equal to 0. What about the range? That's the y values that are included. What comes out of this function? Remember, it goes infinitely, forever. Forever to the right, forever up. But where does it start?
2.
From 2 up. So y greater than or equal to 2.
Wait a second. That's a. Oh, never mind. We're good.
Okay? Now we're going to deal with h of x, which is our reflected function. We're looking at the domain. Again, x belongs to the set of real numbers. But now what is true about our domain?
Negative.
It's going
Wait.
to
It's negative
From
2.
0.
less
All the-
From
than
0 into negative land. So x is less than or equal to 0. All of the x values in the whole number line that are not positive. So all of the x values in the whole number line from 0 moving left to negative infinity. What about the range? Y comes from the set of real numbers. Has our range changed?
Negative 2.
No,
Less
still
Less than
start.
0. Less than 0.
Less than.
Range.
Less than or equal.
Stop talking. Range is the y values. Did our y values change?
No.
No. It still starts here at 2 and goes up. So it's still greater than or equal to 2. Okay, when we did a reflection in the y-axis, our vertical numbers, our coordinates, our y-coordinates did not change. Therefore, the range didn't change. It clearly goes from this up. Our x's changed, though. Instead of moving to the right, they now start at 0 and move to the left. All right, B. B, we are told that r of x is a reflection in the x-axis. So what's it going to look like with respect to f of x if it's a reflection in the x-axis?
Negative f
Good.
of x.
Negative f of x, okay? What this means is any value that you get out, you're just going to change the sign, okay? So here we go. That means we're going to take, so r of x then, says to take f of x, but right in front of f of x, you're going to put a minus sign. So please watch carefully. You have a negative sign, and then we need to keep f of x together in brackets. You must write this step until you are an expert. I still write this step
I don't get
every
it.
single time
I don't get it.
because I am taking the opposite of the whole function. Here's the whole function.
Okay.
So I need to keep it together as a function machine. And once something pops out of that, boom, then I'm going to apply this negative symbol.
Oh, negative f
Okay,
is the whole
so now
function.
if I was going to simplify this expression, which I can do, watch what it becomes. This negative applies to, gets distributed to both terms, negative radical x minus 2. This is the simplified r of x. It's based on r of x equals negative f of x. The negative sign applies to the whole of the function. It applies to both terms within the function. So it's negative radical x negative 2. Okay, what are we going to do with this?
Or can it be any letter?
All right, I'm going to draw f of x again, which is the same as the one that we worked with before. It's a square root function with a vertical translation up 2. So it looks something like this. 1, 2. Okay, good enough. Yours will be more accurate. You know which points it goes through already. It goes over 1 up 1, then it goes over 4 up 2, and then it goes over 9 up 3, and then over 16 up 4. Okay, hopefully that kind of makes sense to you. Those are just square numbers. And what did we say we're going to do? Well, the problem told us we're going to take a reflection over the x-axis. And this is what our new function looks like. We're going to do it by using key points. So 0, 2 was on our original. We're going to take a reflection over the x-axis. That's going to put us at 0, negative 2. 0, negative 2. Instead of going through 1, 3, we're going to go through 1, negative 3. So you can see the distance between this point and the x-axis is 2. The distance between this point and the x-axis is 2. The distance between this point and the x-axis is 3. The distance between this point and the x-axis is 3. Okay? Then as you move along and you get to an x value of 4 and you have a key point of 4, 4, well, we're going to have a key point of 4, negative 4. Yes? And then a key point of 9, 5 turns into a key point, an image point of 9, negative 5. And what you end up having is the exact same shape reflected over the x-axis.
Is that another way to find out the line?
So in example A, the sign of our x-coordinate changed. Now in example B, the sign of our y-coordinate is changing because f of x is the output. Okay? This is the second coordinate in each ordered pair. So what did we draw? We drew r of x, which is negative radical x minus 2. And we compared it to the function f of x that was given in the problem, which is radical x plus 2. And you can see two things here, right? In order to actually do a proper reflection over the x-axis, the shape of my function had to get flipped. So radical x became negative radical x. And it had to move down to where the other one had moved up to.
My book.
Plus 2, minus 2.
Okay.
Good. Let's talk about the domain and range. First for f of x, the domain. That means the values of x that are allowed into the function. You should all have this by now. We already did this exact one, but you should know it anyway. Just look which values of x are going in. Yes?
No, 2.
No.
X values greater than or equal to
One
0.
is 2.
Range is the y values, the output. Which values are coming out? The value of the function represented by your vertical axis
Oh, this is the first one.
goes from 2 all the way up to positive infinity. So y greater than or equal to 2. Now if I'm looking at our reflected function, it was reflected over the x-axis. Did my x-coordinates change?
No.
No, so the restrictions or the domain is going to be the exact same. X is still greater than or equal to 0. Range. Has the range changed?
It moved down too, so
Range. Has the range changed?
Yes.
Yes, the range has changed. It got flipped. So now instead of being y greater than or equal to 2,
negative 2.
y is less than or equal to negative 2. Y is less than or equal to negative 2. Okay? So there you can see the concept of a reflection as well. Greater than 2 now becomes less than negative 2.
One more.
Example 1c, we are told that s of x, pay attention, you can read it right there in front of you, is a reflection in the y-axis and in the x-axis. So how do I write that with respect to f of x?
Negative s of negative x.
Negative x of negative x. It's a reflection in the y-axis. So my x-coordinates are going to have a sign change. And a reflection in the x-axis. So my y-coordinates are going to have a sign change. Now, that means that I'm going to take the whole function f of x, and I'm going to do two things to it. First of all, and I'm going to change my color here so we can be consistent. S of x, I am going to put a negative sign in front of the whole thing. And wherever I see an x, I'm going to replace it with a negative x. Okay, it's the only thing I've changed so far. I just subbed a negative sign in front, and I subbed a negative sign in front of the x. Now to simplify this, I need to apply this negative symbol to both terms. Now don't be confused. I can't somehow sneak this negative inside the square root. You can't do that. Okay, you have the square root of negative x, but you have negative the square root of negative x.
Which is
And you have negative positive 2. Negative 2. No, I literally just said that you can't do that. I literally word for word said you can't do
You
that.
said that, but I didn't understand what
Yes.
you're saying, sorry.
He said you can't sneak it in there.
Okay. Good.
I don't understand the math in that.
It's okay. It's good for us to repeat things, you know?
Yeah. Domain.
Now, there are two reflections. Do I really need to understand what this means and be able to draw this just straight up? No. When I get a problem like this, I need to be able to see that there is a parent function, which is a root function, and I need to be able to see that that parent function has been vertically translated, and then I need to be able to see that it has a reflection, double reflection here, okay? So here we go. We're going to do both of these in one swoop, one fell swoop, one move. You have a graph here. We're going to draw our original again. We're going to note some of its key points at 1, 1, except it's actually 1, 3. And then at 4, 2, but it's actually 4, 4. 0, 2, 1, 3, 4, 4. And what else do we have? 9, 5.
9, 5.
9, 5, if you can fit it on yours. And we're going to apply a double reflection, okay? So we're going to take our values. Let's start with A, which is our first point. We're going to reflect it over the y-axis, which doesn't do anything. If I take my x-coordinate 0 and I make it -0, doesn't do anything, okay? It's still 0. But then I'm going to perform the reflection over the x-axis, which is going to take my y-coordinate and flip it to -2. Okay, so now I have the point 0, -2. Well, what's going to happen to this next point at 1, 3? Well, if I flip the x-coordinate,
It's going to be -1, -3.
I get -1, 3. And then I flip the y-coordinate,
-3.
I get -1, -3. Okay?
-4, -4.
Yep, so, well, yeah. So if I flip the x-coordinate here, that will give me my reflection over the y-axis. So I'm 4 away into -4 land. And instead of 4 positive on the y, I'm going to be 4 negative on the y. So I have -4, -4. Here I had -1, -3. You guessed it, you're going to have -9, -5. And then you draw your new curve through there. And if you did it properly, which you did because you have a nice graph for you, you should have the exact same shape reflected. Whoop, whoop.
Beauty.
Yeah? Could we have done it this way? Down and then over?
Yeah.
Yeah. Okay?
That's what I did.
Doesn't really matter which one you do first. Good, good. The order is not important there. Carrying on. Now we're doing domain and range again. You have 15 seconds to write the domain and range of the original function, which you've now already written twice. Try to think rather than copy. Once you're done that, you can get the domain and range for your new function, s of x. And you can also do that on your own. When you are done, you can double check your answers on the board. Okay, in the last examples, we were given transformations. They told us what transformation to perform. We had to come up with the modified function, the new function, s of x or r of x, whatever we came up with, and then draw the graph of it. This time, they're giving us the graph of the transformed function, and we need to describe the reflection that is happening. So this is f of x, and you also have drawn for you,
G of X.
you also have g of x. Okay, there's g of x. Now you can probably just look at that and tell me what line this thing got reflected over. What would you say?
Reflection of f of x in the y-axis.
X-axis.
It's flipped over the x-axis. If it flipped over the y-axis, it would be over here.
Sure.
Okay? It's not flipped over the x-axis. How's a way that we can double check that? Well,
It's not flipped over the x-axis?
it is flipped over the x-axis.
You said it was.
So the y coordinates are going to change. So that means that this y coordinate of this point is now going to be down here. The x coordinate will not change, but the y coordinate will be negative instead of positive.
See.
What about where the y coordinate is actually negative? Down here at, let's just call it x negative y.
It will be positive.
Yeah, it will be xy. Okay? Now you would never actually really write it this way. This is just xy. And really the one on the red should be the negative one, but a negative is a positive. Anyway, this is just kind of an illustration. I'm going to erase it so that it doesn't live on. But basically you could look at your key points and you could see which of the coordinates is changing. And if it's just changing the sign, you know it's just a reflection, not any other kind of movement. And so how would we describe this? This is a
Reflection of f of x.
reflection
X-axis.
of f of x in the x-axis. It's a vertical flip or a vertical reflection.
Oh, and the next
So
one is a reflection of f of x in the y and x.
Okay, we're looking at the second one. We're looking at key points. You have some key points. You have, for instance, the vertex here is at 4, 2. So you're going to reflect it over the x-axis to be a y-coordinate of -2, and over the x-axis to have an x-coordinate of -4. So your new point is -4, -2, instead of 4, 2. What happened? It got reflected over the x-axis and over the y-axis. You could do that with your other key points. Okay? You could take this key point and you could reflect it over the x-axis and then reflect it over the y-axis. And actually they might not meet where your brain tells you that they're gonna meet originally. But we could take another key point. Let's take this one and I flip it over the x-axis, equidistant from the x-axis, and then flip it over the y-axis, equidistant over the y-axis, and it ends up being a point on this leg way over here. I have to extend it so that you can actually see it. So, which axis did we reflect over?
Both.
Good, so we're going to name this guy f of x, that's our original. We're going to name our transformed function g of x, and we say g of x is a reflection of f of x in both axes. Quick summary, you can reflect over the x-axis. You can reflect over the y-axis. You can reflect over both axes. You could go from negative to positive or from positive to negative. You could go from positive to negative or from negative to positive or both. Okay?
Sure.
Yeah.
Your practice problems that you're responsible for knowing are from page 110. Page 110, numbers 1 through 5 and 9. And note that you have a quiz tomorrow on 2.0 through 2.4.
Noted.
Noted.